Can people in the chat confirm if audio, video, and everything looks fine? We will get started. People in the chat, like, do let me know, like, how many problems were you guys able to solve today? Also, you should check out my Codeforces extension if you are quite regular at the video tutorials that I am creating. Like, it can add like the direct contest link of the from video tutorial links of the contest that I have created. So, for example, if you look at the most recent video tutorial, then hello, am I audible? Like, did three hello? So looks like half of the people are on two problems. Like, not yet. Everyone has voted yet. Yeah, like B was kind of a bit non-trivial. I was trying out a different, like I initially tried out a different problem and then I realized there is a simple solution for B. If you want, I can upload my screencast of the problems. I think the way I feel like is for the problem B, they were expecting you to think of a particular solution. And if you realize it quick enough, it's easier to solve. If you don't, then like it's a nightmare. So if you want, I can upload my screencast on my other YouTube channel and you can find out, like, initially I was trying out a different approach for me and then realized there was a simple solution there. Like, let's wait for a few minutes for more folks to join in. Like, we have still 5 more minutes for us than the scheduled time. B was quite simple but interesting. Like, B is simple if you realize why this problem came in and what problem setter was expecting you to solve for. Otherwise, it's a nightmare. Did A, C, D? Yeah, like actually, number of submission also, like C has more than B, so that's bit understandable. My solution for G, yeah, actually, so like the G involves a lot of simplifications. And then when I realized the simple solution, I first submitted n square brute force while coding and log square solution. Right? So like the way I see it is like most of the problems, the code is small, but the number of steps required to reach that solution is I quite high. So yeah, I think we will definitely discuss G as well. My goal right now is to hit 1900 until October. So all the best actually. Like I'm not sure what your current rating is, but yeah, I use Python. No, actually I have seen grandmasters with Python, so that's fine. So I'm waiting for a couple of more folks to join in. And since this I started the stream a bit early, but we still have 3 more minutes than the scheduled time. So I will just talk to chat for 3 more minutes and then we will start. So like if people in the chat, if you have any more questions, you can let me know because the stream start time is around 10:30 or something. So I have 5 more minutes until 10:30. So we will start it once we have 10:30. So please do post contest discussion fast. Your video editorial actually, like I did also realize my problems are fast, but then I try to explain a lot of stuff and that's how it ends up being long. Yeah, like you can actually refer to my blogs later on if you want to just look for the idea. Like I'm planning to create a hints blog like this. Like this is for previous contest, but I am planning to create similar for this contest as well. And that's where like you should check out my CF editorial expenses. Like if you install this extension, you can find my video editorial link and hints like here. And you can also search for anyone else editorial as well with this one. So I believe it would be quite useful for the folks. Similarly, I also have a Telegram channel where right now I am mostly posting the announcements for the link streams a bit earlier, but I'm also planning to put in more stuff here. So do consider joining Telegram as well. Just an only A, sir. How can I improve? As I didn't understand it. Like, how do you improve? Like, my idea is pretty much same. You should join for now. Like the only advices I have are captured in the Discord server. You can join in the Discord server and look at this roadmap to Red channel. Here I have advices on what you should be doing over here. So you can check over here. Hey Aryan, I chose the strategy of solving 100 problems of a particular rating, move forward with the other, currently doing 1400. I think you can do this, but I would probably advise more on doing virtual contest or something like that. And add code a beginner contest definitely. So this is where we are. Yeah, like I will go through all the problems, just waiting for a couple of more minutes for more folks to join in. Since I started the stream early, but like 10:30 was the actual start time. Why ad coder? Like I have an answer for it. Okay, one second. So couple of more minutes and then we will get started. I'm just searching for the way. So yeah, let's get started now. Okay, let's get started now. Like you can find my ad coder contact handle link in the video description. So let's get started now. So problem is says divide and conquer. You are given two positive integers x and y. You are allowed to perform following operation any number of times. Choose a positive integer z such that z divides x and set x equal to x divided by z. Determine whether you can make x exactly equal to y using this operation. So the problem statement is like this. One second. It says we start from some number x. We can divide it by some number y as long as some number z. If z is divisor of x. And you can notice that this new number is also a divisor of x. So essentially the operation is like this. You have x, you can change it to some divisor of x. And if you apply operation again, it will become divisor divisor of x. And this number is also a divisor of x. And you can keep doing it. And it says, can we make this final number y? Then the only way to do this is like when y is a divisor of x. If this is yes, then what we can do is we can also choose z equal to x divided by y, and then do x divided by z, which would become x divided by y, which would be y. So the answer is yes if y is a divisor of x, otherwise the answer is no. And this is the pretty much the solution for this problem. You take x and y as input, you divide y by x. If that gives you a reminder 0, then y is a divisor of x, print yes, otherwise print no. Any questions, anyone, on the first problem before we move on to the next problem? So this is actually the first problem. Now let's move on to problem B. Problem B says an integer n is said to be good if it contains at most two distinct digits in its decimal representation. For example, 3, 8, 5, 8, 8, 67 are good, whereas integer 1, 2, 3, 9, 4, 4, 7 are not good. You are given an integer x which is good. Your task is to find an integer y such that both of the following conditions are satisfied. Y is good, x into y is also good. It's guaranteed that initially the x is good, and x is between 1 to 10 to the power 8, and y can be from 2 up to 10 to the power 9. So essentially, like the problem statement says, we call an integer good if it contains at most two different digits. So for example, 63, 1, 2, 1, 1, 2, 1 is good. 7, 7, 3, 3, 7 is good. 5, 5, 5 is good. All of these numbers are good. But 1, 2, 3 or 3, 1, 1, 2, 4, these numbers are not good because you can see it contains three different digits, it contains four different digits. Now it says we are given a number x which is a good, contains at max two different digits. We need to take a y which is also good, such that if we multiply x into y, then also we get a good integer. Any suggestions, anyone, on how we should be tackling on this problem? So essentially, let's look at it this way. For example, we have this as a good number. Then good number that can be created with these two digits is like just repeat it to itself. 3, 4, 4, 3, 3, 4, and then 3, 4, 4, 3, 3, 4. You can just repeat this number two times. This will also be good because the original number had only two digits and you are just copying more digits out of it. So like this was the crux of the problem. This is what problem setter wants you to think about. Or for example, if you have 1, 2, 2, 1, then you can just repeat it two times. 1, 2, 2, 1, 1, 2, 2, 1. This will also be good. Or if you have 333, then you if you create 333, this will also be good. Any questions, anyone so far? And our goal is to just choose y such that number becomes x plus x. And this is where we are. And what we can do is, like, for example, if the number is 1, 2, 3, sorry, 1, 1, 2, 1, then if we multiply it by 1, 0, 0, 0, 1, then the number will become 1, 1, 2, 1, 1, 1, 2, 1. And that's the whole idea of this problem. Or for example, if the number is 12, then multiply it by 101. New number will become 12 and 12. Or if the number is 4, 3, 4, 3, 3, 3, then multiply it by 1, 0, 0, 0, 1. And this whole number would become 4, 3, 3, 3, 4, 3, 3, 3. And that's the whole problem here. Now we have to count the number of digits in the given number and then multiply it by, if there are d digits, then multiply it by 10 to the power d plus 1. This should be y. And you can see this digit will only contain 1 and 0. So this is also good. And their product is also good. And this was pretty much what problem setter wants you to think about. So the way to solve this problem is find the power of 10, which is more than the current number, and add plus 1 to it. And that's all you need to do for problem B. Yeah, like how can I build intuition like this? Yeah, like the tricky part over here is, like, you need to try to simplify the solutions and look for simple things over there. One suggestion I can probably give you is, like, if you are starting out, then you can try solving this 100 easy problems. This has few ideas like this. And if you want, you can find solutions of those problems on my GitHub. So, like, basically, I will also upload my screencast for this problem. You can see, like, the first thing that I was trying to do was, like, first you can try to count how many different Y's exist. Like, you can have up to 9 characters over there. So the alternating pattern of the number would be around 2 to the power 9 or something like that. Like, for example, how many different Y's are possible here? Key, like, for example, first, the number of ways to choose 2 characters will not be more than 100. 10 for the first character, 10 for the second character. The actual volume can be even low, but yeah. And then how many different ways you can choose the second total number of digits using 2 characters. If you have 9 characters at each place, like, for example, like, the first approach that came to my mind was as follows: how many different y exists, and can I try all y and check x into y? I don't have a solution handy. Like, so my idea was like you can have select two digits can be in 10 into 10 different ways. And because y can have up to 9 digits, each position can have up to 2 to the power 9. So you will have 2 to the power 9 choices, something like that. So overall 100 into 2 to the power 9 is 512. These are the possible number of y's. And my very first intuition was to try out all the y for a given x and check if it works or not. You have 10 to the power 4 test cases. This will be just in time or something. Okay, it gave TLE, I'm not sure. So, like, that was the first intuition that came to my mind. I started coding on this one, and then I realized like I can just choose 1001 or something like that. And that's where we are. So, like, first idea was to go for this, and then whenever the problem A and B are like this, the always idea is can you try to think of something simpler? And that will always work pretty much every time. Okay, no sir, it got really okay. I believe then that's great because I did try to go. I coded half of that idea, and then I was like, this is getting too hard for the problem B. So think for something simpler. So this is where we are. Anyone question anyone on any of the problems so far? If not, then we will move on to problem C. And actually, we have a very good blog by Dominator, which I would strongly recommend you to solve. Like, I would strongly recommend you to read this idea, and like this is one of the strategies from this contest. So, like these are really really useful basic ideas that are pretty much useful at a lot of times. So let's move to problem C then. You are given a binary string S consists of characters from 0 and 1. In one operation, you can choose the following. Choose a substring S such that that is a palindrome of length at least 2. Delete exactly one character from the chosen string. The remaining parts of the string are then concatenated to form a new string S. Find the minimum possible length of S that can be achieved after applying this operation any number of times. And like the overall idea is like the problem statement is like this. You are given a string of zeros and ones. In any step, what you can do is you can choose a substring that is a palindrome and remove one character from it. For example, this. And the ask is what is the smallest number of characters we can get? And like again, like the way I was thinking about this problem is let's try to write down different numbers and see what all simplifications we can make. For example, if I start with a string like this, Then the very first simplification that I can possibly make over here is like I can choose all the consecutive strings of equal character and try to keep deleting the characters from them. So this part becomes 1. Then I try to choose repeatedly this part, remove one of the zeros. Then I choose the same part, remove one of the zeros, and so on. Then I choose this part, remove all the repeating characters, remove all the repeating characters. Here it's same. Here also remove all the repeating characters. And like if I try to play around, this is one thing that I can possibly think of, right? Okay, like the beauty of this problem is whatever simplification you try to do, like that will always be lead you to the correct answer only. And for this part also, you can try to delete all the equal characters. Like that's the most simple optimization you can try to do. Like if you are given a string, like this is the most simplest way to put numbers out. Like palindrome is like the string that it's same from front and back. But if all the characters are equal, then that is always a palindrome. So if so, the most simpler thing that I can possibly do at first is remove all the adjacent characters or equal characters and try to delete them. And if I do something like this, then my string will become like this: 1 0 1 0 1 0 1 and something like that. And you can notice if either you can have a string like this or you will have a string like this 1 0 1 0 1 0 1 0, because after you delete equal adjacent characters, every character would change. And if you have a string like this, then you can notice that like this complete string is a palindrome. This is a palindrome if the first and last characters are equal. And what you can try to do over here is like you can choose the middlemost character, delete it. Then also it will again be a palindrome. Then also choose a middlemost character, delete it. Then choose a middlemost character, delete it. Then choose a middlemost character, delete it. And then again, every time you delete a middlemost character, the remaining string is still a palindrome. You keep deleting the middlemost characters, you will end up with a string like this, and then you can delete one of the characters from there and you are done. So if you have a string like this, then the answer is 1 length. And if I have to go back from here to here, what I can say is that if the first and last characters are same, I can always make a string of length 1. First, I can delete adjacent characters, and then like whatever the remaining string, that complete string will always be a palindrome. I can keep deleting the middlemost characters, and then I'm done. The problem starts when you have a string like this remaining. What you can do over here is the complete string is not a palindrome, but you can still choose everything except the first character and try to keep deleting it. Like solving for this part is same as the previous part. And you can notice that if you keep deleting these characters here, you would be left with 1 and 0 at last. And there is no way to make it one character, single character. Then how do we solve for this problem? Like, is there a way I can make a string that starts with 1, ends with 0, and able to decrease it more than 2 characters? The answer is actually yes as well. Notice that the problem says we can delete any character. So what I can do for this string is I can first choose this part. This would be a palindrome. And then I will delete this last 0 altogether. Now the remaining part is same as the previous part, and we know that we can make it just one character. So we can again make it just 1. And if you keep playing around a lot, you will realize that more often than not, we can keep only one character at last. There are just one exception for it, but that's the main idea for this problem. Like the beauty of this problem is most of the if you start with a random string, you can almost always make it just one character at last. Notice that what happened here in a string like this. First, we try to get rid of this last zero by choosing a string like this and then trying to solve for the remaining part. What would be the case when we cannot choose a string like this? That would be the case when we have a string like this. Like if there are just two characters, then we won't be able to choose a palindromic substring altogether as well. One zero or zero one. These two cannot be decreased further, but everything else can be reduced a bit further. And if we cannot decrease one zero and zero one, you can try to think of by extension that if the original string is like this, then also we cannot remove all the zeros and all the ones. Because any palindromic string you choose cannot contain both zeros and ones, because if you choose zero one, there is no zero at the back of the it. Similarly, it goes for this. So if the string is like this, then the best we can do is we can remove all the zeros, we can remove all the ones, but at least one zero and at least one will remain. And this is pretty much the whole problem here. So the idea is if the string is of form like this, our answer would be 2 because we will have 1 0 or 0 1 at last. Otherwise, the answer is one character. And this was pretty much the solution for this. Any questions, anyone? And the way I can found this is like by looking at how many times the character changes. Like the number of times the characters change would be one. Because only for 0 to 1 and 1 to 0 we can have the same string. This is one way to look at it. Yeah, like count the number of zeros, count the number of ones. If the string contains only one type of character, the answer is 1. Otherwise, if the sorted 0 to 1 or reverse sorted, the answer is 2. Yeah, like that's another way to check for this. So this was problem C. Any questions, anyone? Was F easier than E? Actually, I don't think so. Like E, I felt to be more on some classical lines of counting, while for F, I tried to guess stuff around. So I find it hard to prove F compared to E. So this is where we are. Any questions, anyone? Before we jump on to the next problem. Like code being simple does not mean like the problem itself is simple. Like is more along the lines ki if you have seen similar ideas before, you will find it easier. While that's not the case. Any questions, anyone on problem C? If not, then we will jump onto the problem D. Okay, let's move on to problem D then. Like do react something so that I know that you understood it and we can move on to the next problem. So let's look at the problem D, an alternative way. Okay, sir, in problem C, we can also think like that we end up with 2 as the smallest length only when we have 0 followed by all ones or 1. Yeah, like actually that's the solution, Aditya. Now it only remains how do we check for this condition. You are given two arrays A and B, each of length n. You are allowed to perform following operation on A any number of times, including 0. Choose two indexes L and R. For each index I from L to R, set AI equal to AI minus 1 if I minus L is odd, AI equal to AI plus 1 if I minus L is even. Determine whether you can make the. So, like the problem essentially says we are given an array A. Also, notice that the problem never says that A cannot number integers on A cannot be negative. We can make it negative is as well if we want to. So, for example, if you choose this as a subarray, then the L is would be 3, I is 3. So, this character L minus I is odd. This becomes plus 1. This becomes minus 1. This becomes plus 1. This becomes minus 1. And then we can choose some another index as well. We can do the same plus 1, minus 1 logic there, and we can keep going. So, overall, the idea is like in the complete subarray, you choose some part of it and do a plus 1, minus 1, plus 1, minus 1, plus 1, or minus 1. If it's odd, then it just remains plus 1 over there. And this is what we can do here. Now, can you notice something peculiar here? If we have plus 1, minus 1, plus 1, minus 1, plus 1, minus 1, then if I look at these numbers, their sum increases by plus 1. But if I choose these numbers, sum has not really changed. So it's kind of like you choose a subarray, you remove 1 from nearby element to the left side. And if the length was odd, you just keep plus 1, no borrowing from the right side. If I look at this part, sum has increased by 1, but if I look at this part, sum has not really changed. Now, if I look at this part again, sum has changed to plus 1 again. Or like, let's probably go for even simpler part here first. If we have plus 1, minus 1, plus 1, minus 1, plus 1, minus 1, plus 1 here, then we can actually break it into multiple operations such that we can first choose these two indexes, do a plus 1, minus 1. Then we can choose these two indexes, do a plus 1, minus 1. Then we can choose these two indexes, do a plus 1, minus 1, and then we can choose this and do just a plus 1. So the idea is like either I will choose length 2 or length 1. No need to choose the bigger length, because if we have a bigger length, for example, plus 1, minus 1, plus 1, we can make it a two operation, one operation of length 2 and one operation of length 1. Or if we have plus 1, minus 1, plus 1, minus 1, we can make it one operation and we can make it the other operation. So like doing only length 1, 2 is sufficient. Any questions, anyone so far? And once we realize this, then length 1 is choose an index and do a plus 1 there. Length 2 is plus 1, minus 1. It's kind of saying that you can choose some number and move it to the left side. If you have noticed so far here, then we are actually done. What we can do here, like for example, we have A1, A2, A3, A4, A5, A6, and so on. We have B1, B2, B3, B4, B5, B6. Notice that we cannot decrease A1, so we should have the case that A1 is less than equal to B1, because there is no number before A1 to decrease it. So what we can do here is we can take the difference of these two numbers and do a plus D here and a minus D here. Then we can look at the difference of these two numbers and increase A with whatever value we want to do after fixing A1 equal to B1. And this will decrease B3 by something. Then we again look at the difference of these two numbers. We increase A3 by required amount and decrease A4 by the same amount, and we can keep going. And at any time, if AI becomes more than BI, then we say it's impossible. And this is pretty much the whole solution for this problem. Now you can try to see why it works, but that's where, yeah. Otherwise, we need to increase bi by this value. So we decrease ai plus equal to whatever value we need. And if we have a next part remaining, we decrease the next part by the same value. And that's where we are. And if at last a becomes equal to b, we are good. Otherwise, the answer is no. Like that's all we need to check for this. Now you can possibly try to see like why this boils down to taking some of first x initial numbers and things like that, but this is pretty much the whole solution. Okay, why can't we make a to be in the last exam if we can take both elements and then only first as the subarray? Like if you first take both the elements, like, you start with 1 and 2, right? If you take both the elements first, your array becomes +1 here, -1 here, 2, 1. Now if you take the only the first element, then this will become +1. Your overall array becomes 3, 1, not 1, 1. You don't decrease the value, you always increase the values over there. Yeah, is it not possible to make all equal to b except the array in which first element? Like that's definitely not true. So like this is where we are, and this is actually the problem D. Now there are different ways to implement the same idea, but essentially this is all. Like the idea is first you try a greedy that whenever you are increasing a number, decrease the next element, because decreasing the element is not a big deal, right? We can always increase it because by using a length one operation. So whenever you are increasing something, initially decrease the next number. First, we have proved that we should only care about length one and length two, and then whenever you are, sir, what if we have done the same thing in reverse traversal of the array? Like if you are doing it from reverse, then you should probably start from b by decreasing the values of b. Like it won't be helpful for the last at. Like for example, consider this case. If this is your case, you will first end up increasing it by +1. Then how will you focus for 4 to 3? Like you need to decrease it, right? Then you can possibly try to do it by -1 here, +1. Possibly you can try out the ideas there. Or possibly from reverse also, I think it may work. Not necessary. Like the idea would be like in the case like this, you first increase this. Now you have to decrease it. You do a -1 here and a +1 here, and possibly it will possibly work. Yeah, prefix sum also works. So this was problem D. Any questions, anyone? So I'm not sure how did you actually implemented it. We can possibly take a look at it, but the crux of this problem is this only. Like, what will you do over here? For example, let's say this. You do a 2 here, you do a 5 here, right? You can first increase it. Then if you are in, like, the most important thing is you should always do +1 -1 operations in between, and only +1 should only be done at I equal to n last index. So first, you, for example, here if this is the array, you can make it 6. Now here when you are making the +1, you should do a +1 here and -1 here. So this will become 3, this will become 5. And then you have to again go back and make this 5 to 6. If you just do a +1 here and then a +1 here, then that will definitely give a WN. Yeah, so like if you do +1 only at I equal to n and otherwise +1 -1, then you can possibly go from reverse as well, but you may get a TLE there. Yeah, like I don't want to think from backward. Like you should be thinking from starting only because that's the simplest part. Any questions, anyone on problem D? Otherwise, we will move on to problem E. Any questions, anyone on problem D? If not, we will move on to problem E. Let's do react something so that I know, okay, like we can move on to the next problem. So last call if there are any questions on problem A to D, because when I looked at the poll, most of the folks have solved only 4 problems. So if there are no questions, then I will move on to the next problem. Okay, let's go on problem E. A is an undirected connected graph with no cycles. You are given a tree with n vertices. Each vertex I has an integer value ai written on it. For any two vertices u and v, we define p of u v as a product of values written on the vertices lying on a simple path from u to v. An unordered triplet of distinct vertices u, v, and w is called good only if and only if product of values from u to v, product of values from v to w, and product of values from w to u is a perfect square. Determine the number of good unordered vertices in a given tree. So this is where we are. First, like the problem statement says like that. You have a given tree. So on. We take two vertices u and v, and we take the product of the numbers written on this path. So this is where we are. Let's first forget about the product. How do we calculate sum of numbers on path from u to v? Or like, let's say, how do we count the distance between u to d? Like, how do we do solve for this problem usually? Any ideas, anyone? Like the way we count distance from u to v is usually as follows, using something known as LCM. Like we first, let's say we create a tree like this. For each node, we try to find its distance from the root. This node would have distance 1, this will have distance 1, this will have distance 2, 3, 4. This will also have distance 3, 4. This will have distance 2, this will have distance 3. Now, if I have to count the distance between this and this node, what I usually try to do is I try to find an LCA for it. Then I check distance from 0 root to 4, which is this path, plus distance from 0 to 3. And then now you notice that if I am taking this path and this path, then this path has actually been counted twice. 2 times distance 0 or 0 to 1. Essentially, the distance u and v is root to u plus distance root to v minus 2 times distance root to LCA, right? Similarly, if someone asks you to find the sum of nodes on path from u to v, how will you do it? Like the distance was easier. How do we find sum of nodes on path from u to v? Like we will again have the similar no idea. We will maintain the sum of nodes from root to that node. First, we will take this path. Then we will take this path. But now if we subtract this path 2 times, then we will miss out on LCM. So like the sum becomes no, like not the same formula, the sum becomes root to u plus sum of root to v minus 2 times sum of root to LCA plus the value at LCA. Because when you subtract 2 times, the LCA is gone. Any questions, anyone so far? So this is where we are. And like we can use the same formula for product of the numbers from root to that as well. Because we need product on a path, we can use the same formula. Root to u multiplied by divided by root to LCA square. Instead of subtracting 2 times, you divide by 2 times minus a of LCA. Like this would be my product of nodes from u to v, right? So let's define a new array. Pu is root to u and au is value at u. Then product u to v becomes product from root to u, which is pu, product from root to v, which is pv, into al upon product from root to LCA square. Right? Now my funny critical part over here is we can ignore this part altogether. Al is the value of LCA, value at LCA. So like any questions, anyone so far here? And I am saying since because we only care about whether the value is square or not, we can simply forget about this part altogether. If pu pv into al is square, then pv pu into pv into al divided by something square will also be square. If pu into pv into al is non-square, then pu into pv into al divided by something square will also be non-square. Any questions, anyone? Like this is our formula to find the product of the numbers on two path. I am saying because we only care if the value is square or not, then we can simply forget this denominator altogether. If numerator is square, then dividing by some square number will also give you a square only. If numerator is non-square, then if you divide it by square, then also the number will remain non-square. Like the same odd even logic goes here. Similarly, kind of similar, but not exactly similar. Why is A LCM multiplied? We discussed actually a bit earlier. In case of distance, though, you are only decreasing this path. But if you take the sum of roots, then the node from up to will contain this value as well. and this value as well. If you divide it by 2 times, this value would be gone. So you need to put it back here. Like if you take product of all of these numbers, product of all of these numbers, and divide it by square of these numbers, this value is gone 2 times. But this value does exist in this path. So you need to keep it once. So like first thing to make it simplify, I'm saying let's just forget about what we are dividing for, because we are always dividing by square number. So for all of our practical purposes, product of u to v, we can just assume it to be pu into pv into ALCA. We, in theory, we do have a number that we have to divide by square of something, but we can forget about it altogether, because that does not changes whether a number would be square or not. If this value is square, then the path will also be square. If this value is non-square, the path will also be non-square. Now let's bring in u, v, and w in the picture. Like let's try to put all of these numbers. The distance between product of pu, pv into a, l, uv. Like that would be the product of the first number, right? Technically, you also have p, l, uv square, but let's just forget about it. You can see. Now the second value is, we need to know the product of u and w, pu, pw, al, uw. Now we need LC of uw. That would be the second number. Like this is our original formula, right? Now we have third formula as well. PV, PW, AL, VW. Like this would be the product of all the numbers, right? Let's try to simplify it. You can notice that PU appears 2 times. PV appears 2 times. PW appears 2 times. So our overall formula becomes PU square, PV square, PW square, ALUV, ALC of VW, ALC of UW. Similar to what we did for division, we can forget these parts as well. If these 3 values are square, then multiplying by some square will also give you a square. If these 3 values are non-square, even if you multiply it by some square, you will get a non-square only. Any questions here? So essentially, like if you have u, v, and w, if we have to check, take all the paths between these 2 values, these 3 values, and product of them, and check if that's a square or not. That is as good as checking a into LC of u comma v, a into LC of v comma w, a of LC of u comma w is a square or not. This has boiled down to this. Any questions, anyone so far? Now let me know if everyone is here so far, because I'm hoping the approach so far was still something you could have been able to derive if you knew how to calculate distance sum, etc., and everything. Because distance sum, XOR things do appear multiple times. Now the next step I would take would be a bit non-trivial. So before I take that, like, do let me know if you are with me so far, or if you, and just let me know if you have any questions so far. So like, just, I'm giving you 1 minute back. If anyone has any confusion so far, let me know. Next, I will take start from this formula and move further. I won't go back to the previous part. Now the approach here is, so what we have boiled down to is, if you have UV and W, what we have to do is we have to find pairwise LCS and look at product of numbers on those LCS. And if that value is square, then the overall product would be square, otherwise it's not. Now the next part is, you should try to play around with different numbers on a tree. For example, if you have U here, this would be some LC of UV. You should try to play around how you can choose the other number there. For example, if you have a W like this, and either there would be some LCA like this and some LCA like that. And if you have a case like this, you can notice that this LCA is common between used 2 times, this LCA is used 1 time. Or you can have cases like this as well. UV. If LCA is somewhere, if W is hanging somewhere like this, then this LCA becomes this. This LCA becomes this, something like that. Or if you have U, or if you have U here, then V here, W here, then you can have one number like this and another number like this. Essentially, the crux of this problem is, if you look at these two values, LC of U and V, the most interesting thing, if you try to play around, you will realize it. These cannot be three different numbers. Like, this is the most astounding part you will have, that you can realize by playing around for different cases you can find. If you have a case like this value would be LCA for two pairs, and this value would be LCA for the other pair. If you try to play around this value would be LCA of one number, and this value would be LCA of two numbers. If you have a case like this value would be LCA of two pairs, value would be LCA of three pairs, and so on. And like, that's the most astounding part over here. Okay, at least one value number would be LCA of at least two pairs here. You cannot have all three different LCS. And if you know something known as virtual tree, like, this is actually pretty hard, but this actually proves it. Virtual tree Codeforces, let me see. So like, this is actually a pretty neat, yeah, like, this is one of my favorite blog here. Like, this even generalizes a bit further. Okay, if you have n nodes, or like a tree with n nodes, and if it take d different nodes, And if we look at all the pairwise distance, pairwise LCA, we would actually have DC to LCS, right? But if you look at the unique value, like number of distinct LCA would be less than equal to D minus 1. This would be the generalized version of this problem. So essentially, if you have 5 different values, if you look at all the pairwise LCS for them, the distinct nodes you will get would be just 4, not more than that. If it's 3, then the distinct value would be at max 2. And like this is the most astounding part for this problem. I have actually created one problem using the auxiliary ideas. I think it was on Codeforces. This was actually my problem. That also I think believe I should utilize the same. So now let's go back to our same problem again. It boils down to we had A of LC of u comma v, A of LC of v comma w, A of LC of u comma w. And now we know that one number is repeated 2 times. So for example, if these two are same, then checking if the value is LC or not is as good as checking this particular value is square or not. If these two are the same elements, then their product would always be square. So this is as good as checking if the non-repeated number is a square or not. And if all the values are same, then your number would become x cube. That is as good as checking x is square or not. And this is the gist of the complete problem here. Okay, now what we can choose is, also notice that the problem said that we need to choose unordered pairs. So what problem has boiled down to saying is, we can choose first fix the number that would be repeated once or 3 times. Repeated once. Like if we choose this node and if we want to make it repeated only once, then how can we do it? Like this is how this node would look like. We would have some subtrees here. And this would be, this node will have few fathers as well. Let's go for green part. This would be up to root. You will have some nodes hanging here, some nodes hanging here, some nodes hanging here, some nodes hanging here. Now, not sure which link you are looking for. Now, if you want these numbers to be repeated only once, then the way to choose this would be like this. You can choose u somewhere here, v somewhere here. No, this won't work, right? We can choose, let's say, u from here, v from here, and W somewhere here. So that overall path, this becomes U and V. The LCA with W becomes this. LCA with V becomes this. This would be one way to choose over here. If V is repeated only once, then just look at the parents of this path. Essentially, W should be chosen from the parent, somewhere from the parent of these nodes, and the remaining two values should be chosen from two different subchildrens over here. That's how we can have V repeated only once. Or if we want to make U repeated only once, then the way to ensure would be choose U from this subtree, choose V from this subtree, choose W from this subtree. This would be the way when this would be repeated 3 times. Here this is repeated 1 time. Like these are the only two cases you can have. If you want this node to be repeated one, choose U from one of the child, choose V from some another child, and then choose W from the parent child only. Or if you want this to be repeated 3 times, choose this from 3 different subtrays. And that's how we are done. Or here, this would be repeated 3 times. Here, this would be repeated once, and this would be repeated twice. No, like I am trying to look at using the formula of LCA only. Yeah, like actually, if I look back at it, you can say that this is actually repeated 3 times. And yeah, you feel like it. And the problem actually boils down to it this 3 times only. Okay, like the no, like 1 time 3 time is I am looking at this formula I have. Either I can have all the three LCS for this pair are same, so the value becomes same number multiplied by 3 times, or you will have one LCA that would be LCA for two pairs and the other would be the remaining part. So if I have a case like this, then this would be the LCA of U and W. This would also be the LCA of V and W, and this would be the LCA of U and V. So that's what I mean when I say that this value is repeated 1 time in my product. Like in total, it would definitely be 3 times because this value is a path of 3 times. But my LCA formula, it's repeated only once. And if you have a case like this, then LCA of U and V would also be this node. LCA of V and W would also be this node. LCA of U and W would also be this node. Then in my formula also the same value gets repeated 3 times. And this is all. So now we have to, for all the nodes that have perfect square value on them, we need to count how many ways to choose pair like this. And this is where we are. Any questions, anyone so far? Now the problem is simply counting the values here. Yeah, like you are right. The lower LCA would be once, but overall it would be 3 times in the all product because this value is part of all the three nodes. Any questions, anyone so far? Like, do give me some thumbs up or something so that now I can move into the final chapter of this problem. Any questions, anyone so far here? If not, then we will move further. Yeah, like, so another way to look at it is like this as well. So like this solves the problem. You can either try to count it using two cases like this, or I would put it this way. We have this node. If I look at all the childrens it has, let's also consider the parent as one more child as well. Let's also consider this as a child only. Then we should choose UV and W from three different nodes. Different children. Or another way you can possibly realize over here is in all of these cases, every node is taken two times. This is the only node that's taken three times. Like this path got traced two times. Once you were going with to UV, once you were going to W. This path also got traced two times. Once you were going to U, once you were going to W. This path also got traced two times. Once you were going to U, once you were going to V. And this was the only node that was multiplied three times. In this case, also like this path would be traced two times, once for V, once for W. This would also be traced two times, once for U, once for W. This would also be traced two times, once for V, once for W. And this would be the only node that would be present in all the three nodes. So technically, you are right in overall solution. All the numbers would be multiplied two times, and this particular node would be the only one that would be multiplied three times. So this is where we have. So now we need, let's, if we even assume the parent to be as one more child of this node, then all we need to do is we have to somehow count numbers such that U, V, and W are taken from three different nodes of this tree. And that's all. And one more thing is you can also choose one of the node to be this particular node as well. And that's the complete solution for this problem. Now you have to count it in some way, and that's where we are. So you can either choose one as this node and two nodes from any two different subtrees, or you can choose all the three nodes from different subtrees and call it a day. Like the idea would be like I would arrange all subtree sizes in an array. Sizes of children's. Any random order works for us. We can choose some particular node as the subtree for V. Then we can choose any of from value from this, any value from this, and that will give you the unique base. So the idea would be to put these values in the array. You can choose one particular node to be the mid one. So, and you can choose any value from this side, any value from this side, and you can keep try out. You can keep trying with all the mid values. So this is where we are. Any questions, anyone on the problem statement? Let's go for the implementation now. So let's first find the list of all the perfect square. And for every value, like all we care about is that value is a perfect square or not. We don't really are not multiplying anything. First, we take all the subtree sizes for all the nodes. One DFS for that. Then we do one more DFS. If this value is not a perfect square, then we skip it. We keep size 1 for that particular node itself as well. One for this particular node. This is how you will count the size for the parents. This is where we are. Like now we have all the children's arranged in an array. Take sum of all the values from 0 to mid and sum of all the values from mid plus 1 to m minus 1. Now for this you can use the prefix sum. And this would be the solution for this problem. You can also use another ideas as well, running some like, in fact, my code in the contest is a bit short. I can probably try to optimize it a bit further as well. But yeah, you can do something like that as well. I won't probably go into the explanations for this, but this will also actually work. And I will mostly leave it as an homework exercise to figure out why this is working. Like this would be some simplified way to implement it. And this would be an homework exercise to see why this is equivalent to the previous part. Any questions, anyone on this part? If not, then we will move on to problem F. How doing this same as taking three values from children? I think you can, if you look at the original diagrams we have, like we had two cases. Either we take two values from two different children and one value from the parent one here. So if I call this parent as one more child as well, then this case is same as this only. And one more case was like if you can choose this particular node as well once, the case that I did not care about. Okay, instead of choosing you from here, you choose you from here only. So I considered like these as a different components, and you need to choose three different values from three different components. So this is where we are. Any questions, anyone on problem E? So actually, at this point, I'm not sure how many people realistically solve for C and D and how many solve it using some unethical ways. And over time, it's becoming a bit hard. By the official editorial is out. Like the only factor for the virtual tree was realizing that the formula we had that we need product of three LCS. Like we initially derived a formula saying that if you are looking for the product of this path, then this is same as taking the product of the LCS of each pairwise numbers. Rather than going into a lot of details here, like you only need product of LCA of U and V, product of LCA of V and W, product of LCA of V and W. That's where we were. And the LCA factor came in like, okay, once you have these three pairs, a known fact is that one node would be LCA of at least two pairs. You cannot have three different LCAs for the same values here. And that's how that virtual tree factor came in. Virtual tree, in fact, generalize this factor. Ki if you have a tree, if you take 10 nodes, look at all the. Am I back? Like people in the chat, do let me know. Like the internet crashed. That's all I can say. And his audio, video, etc. looks great. So yeah, like what I was saying was, like if you have a big tree and if you have 10 different nodes, then the number of pairwise LCA you will get would be actually be 10C2, which would be 45 or something. But if you look at the distinct values, it's a known fact that the number of distinct values would be less than equal to 9. And that was the only fact I utilized from what is already proven in the virtual tree. So you can look at it like that's a bit hard algorithm, but that's where we are. Similarly, if you have three nodes, the number of different pairwise elements you will get is three, but the number of distinct values in those three values would be at max two. And that's the only fact we have utilized from the LCF, virtual tree or auxiliary part. So any questions, anyone? This is where we are with problem E. If there are no more questions on problem E, then we will go to problem F. So like, okay, up into some minus, like did you take into factor the cases that even the node U can be used somewhere? And you should also factor into the cases that you have three nodes from the children only, nothing from the parent. So what formula you have up into sum, square, sum, etc. It has two flaws. You can choose three pairs from the children only, nothing from the parent to begin with. Like it's not necessary that one node will always come from parent. If you choose three nodes from three different children, the same node would be LC of all three pairs, and that also works for us. And you should also factor into cases that when U is the only node, U is also involved somewhere, and you have two nodes from two of the children or one from one parent or child, something like that. Any questions, anyone? I think actually I will prefer checking the editorial of problem F once. I am a beginner. I have to start ABC. So yeah, like ABC, you should definitely do it and do it even before Codeforces on, because I made for few assumptions. I can try to hand wave prove it, but let's see. Okay, quite many details here, but yeah. Last call, anyone? If there are no more questions on this one, then I will move on to the next one. Let me know. So the problem F is more like this. Actually, if I had to prove it, I found F to be harder than all of the problems in this contest. Alice and Bob have got a binary string as of length n. They have decided to play a game on it, taking turns alternatively, with Alice moving first. In each move, the player must select a subsequence which has odd number of inversions and delete it. The player who cannot make a move loses. Determine who wins the game, assuming both players play optimally. So the problem is pretty much like this. First, what is an inversion? Inversion, I would state, is the number of pairs of form zeros and ones when you take two nodes from this tree. From the number of ways to choose, one and zero would be the number of inversion. So this pair would be one inversion. This pair would be another inversion. This pair would be one more inversion. This pair would be one more inversion. This pair would be one more inversion. There are way too many inversions here, but these are the ways to choose inversions over here. It says we are given a binary string. Player can choose any substring, any subsequence, basically some set of characters that have odd number of inversions, and then delete those characters. Next player plays from the remaining string, and the game continues. At last, you will reach at a stage where you cannot even find a string that has even number of inversions. And that's when you will lose the game. The problem is you are given a binary string. Now count the number of ways to choose different inversions, and that's where we are. And that's where we are. Any questions, anyone, on the problem statement? Yeah, like actually, it's quite observation based. I would just like I said for problem B, even for this problem, the initial ideas is try to think simpler cases first. Now, since Alice is the player saying it just says that you have to pick a subsequence that has odd inversions. Even the complete string can be the subsequence. So, very simple idea over here is first idea over here is if S contains odd inversions, take full string. If you take full string, nothing will remain for the other players to play on, and you win. No, it's not a DP at all. This would be the very trivial case. If the complete string contains odd inversions, just take everything and remove everything out. Next player doesn't have anything to even pick for, and you will win. So we can check this first. Like there are multiple ways to count inversions. There are well-known ways over here, or you can abuse the fact that the given number has inversions and something like that, and you are done. So that's a simple way. First, if condition to check for. Now, what happens if we take the complete string, but just keep one character for the other player? But keep one character. Then also another player can't do anything. If you have just one character, the number of inversions would be zero. If the character is zero, the inversion is zero. If the character is one, the inversion is zero. Because notice in a binary string, the characters is number of one and zero. So if we can somehow choose the complete string, except keeping one character, and if we can find such a string that has odd inversions, like if we can somehow find a substring where we take the complete string and accept the one character, and if that has odd inversions, then that would be a valid move for us. So if there is a way using which, no, I am actually showing the code, I believe. If there is a way I can just keep one character and the remaining string as odd, then let's play this move out. And the next player will have only one character to focus on, and they cannot choose anything out. In that case, also, I will win. Like two simple cases, not so simple, but I would call it these two as the base cases. Like that, these two are something that if I am playing this game, I should definitely try for it. And the answer is if Alice cannot find a move like this, then Bob will win. If you have two moves like this, play these two. Otherwise, whatever you play, Bob will have more moves and you will have a lot of back and forth, and at last, Bob will. That's pretty much the solution for problem F. Proving it is hard, but right now, this is where we are. Any questions, anyone so far? I will try to prove this one out, but that's where we are. Like the idea is either take the complete string or just keep one character and take all the remaining characters. If you can't do this, then you are lost. And similar to, you remember like the case we had where we had +1, -1, +1, -1, we boiled it down to 2 or 1. Here also, like these two, I would call it a base cases, and that's where we are. Now let's first focus on these two conditions. What made you to doing that without deducing that with the proof? So these two were the base cases, and I was like, let's submit it. If I am get a W, then I will probably chastise something or like that. But in contest, this actually worked. So yeah, like I can now try to give you an hand wavy proof of it. Editorial also has a proof, you can refer to it, but that's where yeah. So if you cannot find a move like this, then what would be the case? Complete string has even inversions, and each character is part of even number of inversions. That's why if you start with all the even inversions, if you just remove one character, if you still have an even number, then you can say that that particular number was part of even number of pairs that were inversions. Can I state it this way? If the complete string, let's say, has 20 inversions, then for example, this particular 0, this will have some ones from here, and this would be the even number of ones. Or if you have a 1 here that you take, the inversions that it would be a part of would be like this. And so every number would contribute even number of inversions. That's where we are. Like, are you with me so far? Like, first two cases were bit trivial to check. If you can find those moves, just play it. Your opponent doesn't even have a move to play around. So there is no way he can pick any string to make you lose. The question is, if you cannot find two moves, then the string you have would be of something like this. For every 0, you will have even number of ones before it. That's why this particular 0 is a part of even number of pairs. And for everyone, you would have odd number of zeros beside it. Or some hand wavy wave. And now this is kind of a special string that Editorial is claiming, and you can check the proof in Editorial definitely. My hand wavy proof would be like this. Like we have numbers here. Let's say I am choosing these pair numbers. Let's say I choose these numbers in orange, and the remaining numbers are what for Bob to play around. What I will try to prove is like if these orange boxes have odd number of inversions, then whatever the remaining characters are there, that also has odd number of characters. So Bob can simply take the complete string in the next move and we are lost. And if this orange boxes have even number of inversion, then I cannot even play it as well. So sounds fair, right? If I can prove that whatever set of values I choose, either that will have even number of inversions, in that case I cannot play that string. Or if that has the odd number of inversions, then the remaining characters will also have odd number of inversions. So Bob can simply take the complete string in the starting and make us lose. Are you with me so far? So like overall the TL is if Alice is winning, then the game will be over in just one move. If Bob is winning, then the game would be over in two moves. There are no more. There is no third move to begin with. So the idea would be like this. Okay, first we took the complete string. Like let's first take the complete string and try to remove the characters that are not in orange box or something like that. Initially, you will have complete box string selected for you. That will have even number of inversions. Then you will remove some number out from here because that pair was part of even number of inversions. So those even number of inversions will go away. And you would be left with this part, and this part will still have even number of inversions with you. Right? Now let's say we even remove, like instead of choosing orange box, I am taking complete box and removing all the characters except the orange one. Then let's say I remove this part as well. This part was also the part of even number of inversions, but it's possible that this also included this particular node as well. So what would be the number of inversions remaining over here? It would be even total minus the even for first one minus even for first one. And if you overcounted it, if both the removed pairs possibly plus 1 or 0. If these two contributed one even pair, then this time it would have odd number of pairs and you will overall remove odd. In this case, the remaining string will also have odd number of inversions. Or you will remove even minus even, and the remaining string is also even. That's where we are. Now let's say we have removed this string as well. Then we would be left with this part. What I'm trying to prove is like if I'm moving one character to someone, either both the sets remain even or both the sets remain odd. There is no other case over there. If the original part was odd, both the sides were odd. Like you see, if you are removing odd, then both the sides become odd because whatever you remove extra from here gets added in the other part. If this part contributes even number of pairs with the other part, then overall you will remove even from the total, and you overcounted the odd one, so you will add them back. Overall number becomes even. Or if this part contributed even number of moves with the other fraction, so you remove overcounting and you are left with even. And whatever you overcounted, and this exact number gets added to the other part as well. So think of it like this. You start with the complete string. It has even number. It has 0, which is an even number. This is an even that has total count. Now you remove one character from here and put it here. Either you will break odd number of pairs from here and also attach form new odd number of pairs. If the removed number has total 10 inversion pairs, and in the remaining character here, if it has 6 inversion pairs, then if you remove this character and bring it here, this will decrease 6 pairs from here and add 4 pairs here. So both the sides remain even. Or if this had, let's say, 3 number of inversions remaining, because the total inversions were 10, when you bring it here, you will remove 3 inversions from here and you will add 7 inversions here. So on both the sides, parity will always be same. Either both the sets will have even numbers or both the sets will have odd number. Doesn't really matter how you move numbers around. So either the set you choose had even number, remaining part is also even, but you cannot play it. Or you play around and move odd numbers out, but now whatever string you are left with, that string has even odd number of inversions. So Bob will simply remove it in one go. And this is the solution for this problem. And this is actually the proof here. Any questions, anyone on the proof here? Because it doesn't really matter how we move numbers around in one set. At the end of the day, final set will have the same number of inversions there. If there are any questions, just let me know. Otherwise, we will look at the code for this one and move to problem G. Or like put in some thumbs up or something, so I know that you have been here. You have no confusion so far. So, any questions, anyone? Hello. So let's look at the code for this one. So the idea is as follows. First, I will count the total number of inversions. I keep a running total of zeros and ones. Whenever I encounter 0, I count the number of ones before it. So, and if the total count inversions is odd, simply take the complete string and Alice wins. Otherwise, we know that the complete string has odd inversions. Now we maintain how many zeros exist once we have seen before and how many zeros exist after it. So if we find a zero, we have to count the number of odd ones before it. If that is true, then we have found one number that has odd number of inverts. So we keep this number and remove everything out. And we decrement the running total of how many zeros are after the values. If we found the odd out, then we count how many zeros are there after this number. If this is odd, then we have found one number that we can keep and everything else will have odd number. And if we have found a number that has odd number of inversions, print Alice, otherwise print Bob. So this is problem F, my friends. Any questions, anyone? Do react something so I know that we are done with problem F and we can move to problem G. So G would be the last problem for today. Like many a times I do take luxury to just implement something without explicitly proving it, but that comes from a strong intuition for the solution so far. So let's move on to the last problem, and that's where we are. For a given array B of length M, define f of B as the minimum possible value of maximum in B and minus minimum in V that can be achieved by performing following operations any number of times. You can choose an index I and add that to the next number or subtract that from the next number. Now we are given an array A of length and our task is to count this for all the subarrays from the array A. More formally determine the value of this A, B, and etc. are there. So this is the problem statement. Does anyone want me to brief you through the problem statement? Or I believe like the problem statement is fairly simple while the solution is not. So I can skip going through the complete problem statement again if no one needs it. Like for rating, I usually refer folks to uclist.by. You can find ratings here. Actually, like this rates around 1500 for problem E and 1800 for problem D and 2400 for problem G. And in the world of AI, you can possibly add plus 300 to it, and that would be how I would rate it. So I will probably say this problem is 1800 or something, and this problem is 2000 or something like that. So this is where we are. Let's first try to solve this for the complete array. Forget about the substring part altogether. Given an array A, how do you find the minimum value of this expression to begin with? And once we figure it out, the remaining part is where we are. Like, I won't make a statement that cheating is that prevalent, but that's some guesstimate that I simply take this point. Like, so that's not a statement on how many people would have solved it, but that's some hand wavy estimate that I'm right. So, like, let's notice when this value can be zero. Like, that's the best minimum value you can have, right? You have an array that has minimum and maximum equal, and the difference is zero. So we have an array A. Maximum of A minus minimum of A. If we can make everything equal, then the value is 0. So when can we make everything equal to 0? First, let's focus on even the very first number. Is there any element that we cannot change? Like notice that the operation is, so we cannot change A1, right? So we know that maximum of A would be greater than equal to A1. Minimum of A would be less than equal to A1. Can we make A2 equal to A1? So like our goal becomes make all numbers close to A1 because A1 definitely exists. Now we should try to make it closer to A1 and that's where we are. What can we do over here? First, let's say for example, we have 10 here and 94 here. And then we have some numbers here. What we can do is we can first subtract 10 repeatedly from here, minus 10, minus 10, minus 10, minus 10, so on. We would be left with 10 and 4 and some number part. In this case, like the difference between these two is 6. Or after doing subtraction, if we add it, the number will become 10, 14 and something like that. In that case, the difference is 4. This is a pretty interesting part because what I will try to show you is if this is the case, then we can keep all the numbers between 10 to 14. If this is the case, then we can keep all the numbers between 4 and 10. So you will always have one number as the maximum and just the next number as the minimum, or one number as the minimum and just the other number as the maximum. Like my claim is like if we can we'll make array like this, and that's where we are. So like let's say we reached over here so far. Now what can we do for the next number? We can repeatedly subtract 4 from here to make this value a number between 0 and 3. Let's say we end up with 3 here. And then let's say we made the next number, we kept subtracting it until it became somewhere from 0 and 2 and so on. Like you can see, if I start with 10, 94 and something, then first I can subtract 10 from the first number, then I can keep subtracting 4 from the next number, then I can keep subtracting 3 from the 2 number and so on. I can make it a decreasing sequence. Are you with me so far with the bold claim that I can make the complete array decreasing sequence by first repeatedly subtracting A2 by A1 until it becomes less than equal to A1? Then I can repeatedly subtract A3 by A2 and make it less than 1 and so on. So now I am left with an array that looks like this: 10, 4, 3, 3, 2, 1 and so on. In this case, like for 10 and 4, the ideal world is we change this to 14 so that the difference between 10 and 4 is 6. So what I would be trying to, I will figure out a way using which I will add this 10 to all of these numbers. So my numbers will become 10, 14, 13, 13, 12, 11, things like that. So I would be, because my this sequence was a decreasing sequence. If I add 10 to everything, this will still remain a decreasing sequence. So this would be my minimum. This would be my maximum. And I don't really care about the other numbers. How can I obtain a sequence like this? An important observation is like the problem statement never really says that we cannot have negative numbers. You can, it never says that we cannot have negative numbers in between. So what do I do over here? I first subtract this number from here. This becomes -1. Then I subtract this from here. This becomes -1. Then I subtract this from here. This becomes 0. Then I subtract 4 from here. This becomes -1. And we have 4 and 10. First subtract all the pairs here. Now add 10 to this number. This becomes 10 and 14. Now you add this 14 to this number. This will become 13. Now you add 13 to this number. This number will also become 13. Now you add 13 to this number. This will become 12. Now you add 12 to this number. This number will become 11. So we ended up adding 10 to everything. So this is one way to keep the numbers here. So I can make these numbers like this, where 14 is the maximum and 10 is the minimum. So this is one place here for us. Now let's go to 10, 4, 3, 3, 2, 1, things like that. Like this is the last question. What I'm claiming is like I can also keep this part between 4 to 10 as well. So how do I do it? So like I can definitely add 4 to everything using the same algorithm here. Like I added 10 to everything, all the remaining next part here as well. Using the same way, I can also add 4 to everything here. But would I like to do that? Like first of all, if we want to keep this number small, like what will we do? Like for example, if the second number becomes somewhere between 0 to 5, it's better to make it 10 to 15. If the number is from 6 to 10, then keep it 6 to 10. So if I want to keep this number as second number as 7, then that would be more than half here. Then I would have numbers like this: 6, 6, 4, 3, 2, 1, so on. Looks good, right? Like the immediate number, if I want to keep it less than the other number, then it would be at least more than the half of this, like. And this is how my remaining sequence is. Now, what can I do over here? I can first make this number a -3, like essentially negative of a1 by 2. Some negative overall value is less than a1 by 2. That's fine, right? I can, because problem never says ki I cannot have negative numbers. Now I go over similarly to the previous way. I go over this sequence. Make all of these less than equal to 3. I start with negative number here. Instead of subtracting it, I can use the same previous algorithm to even. Previously, I added some number to some sequence, right? I can also use the similar algorithm over here as well. You can work out the detail, but the idea is, and I can basically make everything here between 0 to 3. You can play around with the similar algorithm here where you first subtracted some part, added some part, made everything plus 1. Like, let's first even look at this number as well. You have 10, 14, 13, 12, 11, 11, so on. You can just do the reverse of the previous number to even subtract 10 from everything as well. First subtract 11 from here, it becomes 0. Then subtract 12 from here, it becomes minus 1. Then subtract 13 from here, it becomes minus 1. Then subtract 14 from here, it becomes minus 1. Then subtract 4 from here, it becomes 4. 10. Then add 4 here, this value will become 3. Add 3 here, this value will become 2. Add 2 here, this value will become 1. Add 1 here, this value will become 1. So essentially, I can, just like I added 10 to everything, I can use the reverse operation to subtract 10 from everything as well. So first, when I had 10 and 7, I made it a negative number. And instead of doing subtraction here, whenever I have to subtract it, I do a plus sign or negative sign. And I can play around to make all of these values between 0 and 3. And again, the decreasing property holds true as well. So I have 10 here, minus 3 here. And this set that contains values between 0 to 3. Right? Any questions here so far? And the same idea would remain, like now go back and add plus. And what I would say is I would first make 0 to 3 everywhere. And then I can add minus 3 in that part. So my numbers would be like this: 10, minus 3, sub segment here, where the values are between minus 3 to 0. If the values are from 0 to 3, if you subtract minus 3 in the same range, like subtracting minus 3 is same as saying that add minus 3 to this range. Now the values are between minus 3 to 0. Now go back and add 10 to everything. You would have 10 here, 7 here, and here you would have numbers between 7 to 10. So overall, you can play around here, but the TLDR for this idea was if you only care about A1 and A2, make these as close as possible, and that's your answer. And this would be the value of like the idea is like because for A2 you can use only A1. So there are fixed number of values for A2 you can actually make with. And whatever minimum maximum difference you can find between these two, your answer would be at least of that value. For example, in 10 and 7, you know that you cannot make the difference of these two numbers less than 3 because you can subtract 10 from 7 to make it minus 3 or add 10 to 7 to make it 17. And so whatever minimum and maximum you will can find over here, this value is always fixed. Whatever difference you can make over here, that would be the minimum value you can get for an answer. And I have shown you the algorithm using which you can keep whatever value you got here as your final answer, and everything else is between these two numbers. You can do it with 10 and 7, or if you keep 10 and 4, then how you can would, if you want to keep it 10 and 14, then how you keep everything between 10 and 14. So the TLDR is A1 and A2. Using A1 and A2, just try to find the minimum difference from A1 and A2, and whatever you have got, that's your answer. You don't have to even bother about A3 to AN. That's how you will solve it for the complete array. We are still yet to go for the subarrays. Any questions, anyone so far? Just do some thumbs up or something, then we will move on to the next part for this problem. So, like the only if and buts on this part is this. For example, if you have 10 here and 150 here, and then some other. Yeah, like I'm not planning like one shot. This editorial is what I have. If I have to go through a detailed video on everything, that will even take few more hours, and I don't have actually that much time as well. Like this particular video itself takes 2.5 hours here, and 2.5 hours for the contest as well. So if I try to make a detailed video, then that would take 3 to 5 days. So don't want to discourage it, but that's where we are. And most of the folks will not be interested in a detailed video 5 days after the contest. So that's where we are. So like most of the time, the sim is the most easiest one. I can take questions from the audience, answer them, and move on. In this case, if you have 10 and 150 here, if you keep subtracting here, you will either end up with 10, 0, or 20. And the most legit choice here is to keep 10. So you would end up with 10, 10, and more parts over here. Only in the case like this, you will have to now check with A3 as well. Because these 10, 10 doesn't give us anything, and the problem still remains the same. Even if we delete this element, the values remain here. So overall, like what we need to care about is like we would have 10 as the first number, then we will have some tens, and then there would be one number that cannot be 10. So essentially, this number and this number actually decides what would be the value of the array, and that's where we are. Any questions, anyone so far? And when can all the values be 10? If these values are multiples of 10. So in this case, for these subarrays, the value would be 0, and this one would be the value for everything. So my like this is where we are. How do we solve it for one array? Any questions, anyone? If not, then we will quickly solve for the subarray one, and we would be done. So now, if we have to solve for some subarrays, A1, A2, A3, A4, A5, A6, and so on. Now, for example, if this is my AL, and if I have to calculate it for all the subarrays and so forth, then what I would have is initially some numbers would be multiples of AL up to some values. And in this case, if my right endpoint is here and left endpoint is here, the value would be 0. Or if right endpoint, left endpoint is here, right endpoint is here, the value is 0. And then we will have one number that will not be the multiple of 10. And essentially, these two values will be enough to decide the fate of all the right endpoints that are here. If my R is here, left is here, then also these two values have decided the fate over here. If R is here, left is here, these values have decided the fate for it. So I can choose this left endpoint, this right endpoint, find the value of it and multiply it by the number of indexes that exist on this side. And for if the value is here, then the amount is 0. So this is how I would be doing it. So for all the left numbers, I have to find how many next numbers are the multiple of the current number. So if I have to jump onto the code for this, I have taken array as input. This get value finds the array where I know the first value and I know the next value that is not the multiple of that number. I choose one left number. Let's say I am doing some black magic here and I magically found out the next value that is not a multiple of AL. Then I figure out the value using those two numbers and multiply it by number of indexes that exist beyond R. And how do I found it for the first number and second number? I first simply take the mod. That would be the number I keep getting, subtracting it. Then I can either keep that number y only. In that case, the answer would be absolute of x comma y. Or I would add x to that number and the answer would be the absolute value of that number. So that's how I would solve it for the all the parts. The only remain is find the next index that is not the multiple of this number. Any questions here? So the problem is reduced to given an index I. Look at the right side. Find the first number that is not the multiple of a. Okay. And if I can solve for this reduced problem now, then I am done. Any questions, anyone so far? Huh. Yeah, like so the way I can do is, yeah, I think I wrote x. Yeah, like that was a bit intentional. This is just y only, absolute value of y. The idea is first number becomes x and the next number becomes y. Either keep it directly or keep it x and x plus y and take difference from this. So we have absolute value here. So these two are the combinations here. This will the smallest positive value you will get by keep repeatedly subtracting. And that's where it. So one way to do over here is like, if you don't know much, what you can do is you can use a segment tree to find GCD on a range. And do a binary search to find J. Like the idea would be you would start from I. You would have something for, and this would be the mid. If all of these GCD AI divides GCD, then you know that every number is a multiple of AI. If it doesn't, if it divides it, then now you have to search on this half. If AI does not divide GCD, then you have to search on this half. And this is how you can find the first index that is not a multiple of AI. And AdCoder library, I also have AdCoder library. And I previously created a video on how to install AdCoder library as well. Or you can use the maxWrite function directly from this library if you don't want to do binary search on your own. It takes black box as an input, like the checker function for binary search. Like this is the segment tree where each element contains the GCD of the range, and this would be the checker. I am saying like if the GCD is divides here, then that is the right part or the left part. And you can possibly use segment tree from AdCoder library directly with maxWrite function to find the same index. Behind the scenes, it does the binary search for you. So, like, did you remember like what I told you? Like, if you don't have to not use maxWrite, then how can you solve this problem? Did you understood that part? How you can do a binary search, look at the GCD of range, and move from either the right side or the left side. Like, let's forget about maxWrite and ACL. Can you solve this problem? Yeah. So all I have to say is like maxWrite behind the scene is doing that binary search for you only. That's the statement. So that binary search can be one line rather than using mid, low, high if you are using ACL library. That's what it does. You can look at like you can look at the documentation of ACL library as well. It has the segment tree monad and something where we are keeping GCD on the segment tree to find the range over here. Now the max set it says it applies binary search on segment tree. The function f of x should be some conditions on it. Like if we give a left endpoint, call it with the left endpoint with some function, then either it will give some L to R or it will give us some right endpoint such that before that right endpoint that function is true and after that it's false. The same definition of the binary search. So it will find the next endpoint from AL to that point where you will have a GCD there. Similarly, we also have min left defined as well if you want to do a binary search on left side. And behind the scenes, actually, I think overall, if you do a manual binary search, with segmentary calls, you will have log and iterations for the binary search. And each call for the range call, you will have log and queries as well. So overall, your binary search is log square n. This is not taking into account the factor that you also have GCD involved in the product as well. Overall, this whole process would be log square n because you are doing log n iterations for mid, and for each mid, you are taking a segmentary call from L to mid, and that segmentary call itself will also take log n. So overall, this whole process would be log square n. Behind the scenes, this maxWrite function solves it in log n only. So one additional factor also goes away. Okay, not just the binary search, behind the scenes, it solves the binary search plus range query is in log n instead of log square n. If you are doing it manually, then it's log square n. I'm not even considering the time complexity for calculating GCD. So this is also one optimization that can come handy multiple times. One second, I'm not sure why my keyboard is not working. So that optimization is from something that known as walk on segment tree. And like this would actually be an homework exercise if you want to go for want to see how that min max implemented over here. So you can read it from USA CEO guide here. Walking on a segment tree. Pretty good problem. You can solve for some CSS problems at all. So MaxSite essentially does a binary search for you, and it also optimizes one more factor where that is log n instead of log square n if you go by doing it manually. So my first recommendation is if you are hearing it for the first time, then first implement it on your own without using segment tree library, and then you use segment tree as a black box from Coder library the next time. So, all right, guys, this was all I had for today's contest. And if you have any more questions for me, just let me know. I will spend a couple of more minutes. It's been around almost 3 hours now. So, I will wrap up this stream today. Thanks, everyone who has been here so far. So, this is where we are. Binary search, actually, I have an advice. If you want to learn binary search, then go through this. This problem can also be solved using lazy segment tree, right? Whatever problems you can solve using a segment tree, you can also put a lazy there. But you don't really need any update operations for the lazy part. So you can import lazy there, but you won't be applying any lazy operations there to do it. So the answer is yes, because any problem that can be solved using segment tree can also be solved using lazy segment tree. But we don't need any special features from lazy segment tree to solve this problem. So if you are searching for binary search, do read this out. Like, how do I say if B is hacked or not? Like, I don't know, like, what all people are doing. Man, like, I'm happy that this solution got hacked. Otherwise, obfuscating code like this is actually a bannable offense on Codeforces. Even if this submission is not hacked, this guy can get hacked over here. Like, man, I don't know why people need red, black tree, segment tree, etc. over here. Looks like some way to avoid possibly from Telegram or something. Okay, this is adding all the numbers. That's what I was trying to do. V contains all the numbers. Up to length n. Then it converts n to the string. It looks like this is trying to multiply all the numbers. The initial solution that I did tossed around later on and people said TLE, like this is the TLE party. So like if you are calculating all the possible y's and then try to check if x multiplied by y will give you the required number or not, then that would be a TLE. And the time limit here is 1 second, I believe. And if your submission takes more than 700 seconds or something on this problem, then most likely it will get hacked. Wait, apparently it looks like someone at the top got hacked. Like I started with rank 31, if I remember correctly, and now I am at 14 rank. Let's see who got hacked from the top. No, it looks like people got hacked on the last problem. Man, this is 62 seconds, and why did Igor got hacked? At this point, I would be surprised if even my solution gets hacked. Like, did the solution that I explained to you guys is not correct? Why are they like these people getting hacked? I believe something is not right over here. Like, I won't believe if you say to me that these folks have a wrong solution of G and my solution is right. Like, all of these are ex legendary grandmaster, and it looks like this particular guy hacked everyone. Yeah, like the same guy hacked everyone, man, literally. Let's see what is happening on the announcement screen. At this point, I don't know what was the problem in ICPC online prelims 2025 or something. No, why you need 120? Like, I'm a bit surprised. Like, legendary grandmasters got hacked. And okay, yeah, author solution in G is wrong. So yeah, this explains it. Okay, I can probably put a clickbait that I went from 31 to rank 8. Let's just wait for a few seconds. I will jump to rank 1 and then back to 31 because someone is hacking people from the top. Let's just, this is crazy world to be. Let's just refresh it for some time. So if author solution is, it looks like the person who was hacking everyone got banned. So that's very. So possibly like the person cannot hack us because Codeforces banned them from hacking because he was hacking everyone on this problem. So yeah, like let's take a screenshot for this and possibly. I think my best rank was probably 2 in a due to and 2 and 4 in due to or something. You get points for hacking, right? No. Points for hacking is only when the contest is running, which is usually due 1, due 2. No hacking points for due 3 and due 4 and education lab. So Kotatsugame, like, yeah, like the solution. Same at coder GCD max right. If x is 0 or x equal to a, then yeah, interesting world to be living. But, so yeah, this is where we are. Like this solution is same as mine. Like different people have different ways to use GCD. You can check out this blog. Like the Codeforces implementation of GCD, and the manual functions are widely different. So like this guy got TLE for using the different GCD from internal implementation. So that makes sense. At least if you are legendary grandmaster or something, it won't be great ki you got hacked just because you used a built-in GCD and someone abused how that is implemented. So it won't. It doesn't hurt to keep a fixed solution in your code to begin with. So what's more surprising is like the author solution is wrong in the case that they haven't accounted for the cases when the number can overflow. Like let's just say we are too small that if we get hacked by it, that Codeforces blog will have n number of downloads. So yeah. So like all of these author will fix his answer and all of this would get invalidated. That's what I would say. Should we try to construct a test case where man what? Can the answer be more than signed 64-bit integer? It cannot be right. Man, I believe even my solution will get hacked over it. Like I have used long int and the numbers can be up to 10 to the power 9. You have 10 to the power 9 pairs or something like that. Let's hack for it. At this point, I'm sure that everyone's solution for G would be wrong. The idea is correct, just that all of us are using long instead of the other one. Let's actually construct the test case for it and hack my own solution and then let's move on. I hope nobody will hack me. So we need to construct test cases where the pairs have differences of 10 to the power 9. How can we do that? We can take 2 into 10 to the power 9, 1 into 10 to the power 9 plus 1, and so on. Huh. Let's just put only one test case. 2e9 is the maximum number we can. All the numbers are between 1e9, right? And y would be x divided by 2 plus 1. And the number of, yeah, like that would have worked. Let's put y at odd numbers. This would be my hack test case for it. Look, remove pragma. Okay, this is printing right. Like, I am trying to create a test case where my solution will print negative numbers. Nevertheless, let's try this hack once. Man, it's hacked before I can even try. So I am gone. What is my updated rank now? And the only thing that I would like to say is, at least you should have allowed me to hack myself. But yeah, let's try out a random solution. No, I think that I did not took that screenshot, but I can always take screenshot from my video, right? Video does has it. And by the way, my best rank is due 2 in due to and 4 in due to. So 8 is actually not my best rank. Mm-hmm. Like, uh-huh. Mhm. Huh. Okay, at least my hack did not succeeded here. So what we really need is we need to look at the author solution from the editorial and hack it. Mhm. What is this guy doing? Uh, okay, is it abusing this fact somewhere? Like this somehow becomes negative, or what exactly is it? Like at least support this one. Okay, I cannot read it, but yeah. Like, what would be the maximum answer here? Like, we have numbers up to 2 into 10 to the power 5. Okay, it looks like someone has removed those x. Mhm. Like, let's try to see what is the maximum possible answer, and that's how we know that whether our solution is safe or not, or we should have used int 120. There are two possibilities: everyone is wrong, or the number is up to 2 into 10 to the power 5. And the maximum AI is 10 to the power 9. So the maximum answer you will always get is AI divided by 2. You have n into n minus 1 divided by 2 subarrays into the maximum value. This is our maximum value we can have in the answer. Let's check how much. This is 9 into 10 to the power 18 or something like that. So this will definitely overflow into 128. The maximum value we can get is 9 into 2 to the power 3 or something like that. So this is where we are. Now, can we somehow decrease these bounds? Because I don't think we can decrease with max. Yeah, to begin with. Like the hack I have created was more than half of this because I was taking the pairs of 2 to 2. Hmm. So the next thing I will probably test for is this is what I would be testing for it. This would be my next. And that's what we would try for. I think that's fine. Okay, this is not working out. So like this is the maximum answer that I could think of. This value is more than that. Uh-huh. At least I'm not able to come up with the test case where it works abuser. Hmm. Let's try. Let's just skip it this way. Huh. Okay, I was able to produce 666 or things like that. 666 is possible. Which divided by check? Any suggestion? This gave me the biggest answer, 666 or something. And K is just 2. 9102. So this was actually by design. If I don't do this, then I will have to start with this. Let's try it. Like, it will give way too small results. Because what we need is the number that is as close as our value. And if I put it this, then the values would be. So divide by 2 was needed, otherwise the value would be x by v only. That's way too small. Okay, I see what you mean. Should I multiply it by 0.66? So this 2 is required to make the number in between. Hmm. So I think I will call it a day. To me, looks like something might be wrong with the author solution, or we don't know. Like, we will find. Apology in mistaken. So yeah, I think we are done. Author says ki long int will not pass, and that's where we are. So if you are looking for a correct solution, this is what you should be printing. And yeah, this is how you need to deal with. I'm not sure why it says my G is pass, but yeah. So yeah, pretty neat. Okay, we need to use segment tree as well. Yeah. So that's all. So yeah, like sometimes you solve problem and sometimes you leave it. So we can technically claim that we did solve it, but yeah. If the author knew this number would have got a overflow, they would have changed it to something small as well. Okay. They updated the problem statement to say this. So if author knew it, this would have been the case then. So thanks everyone. And I will wrap up the stream for today.